Chapter 5. Fractions. Look at the following 4 figures. In figure 1, a square has been divided into 4 equal parts. One part out of 4 has been shaded, that is, 1/4 has been shaded. Mathematically, we can say 1/4 portion has been shaded. In figure 2, a rectangular sheet has been divided into 6 equal parts. Out of 6, 5 parts have been shaded, that is, 5/6 portion of rectangular sheet has been shaded. 1 part out of 6, that is, 1/6, remains unshaded. In figure 3, a circle has been divided into 4 equal parts. 3 parts out of 4, that is, 3/4 is red. In other words, 3/4 is red. 1 part out of 4, 1/4, that is, 1/4 remains white. In figure 4, there are 5 pillars. 3 pillars out of 5, 3/5 are coloured. Mathematically, 3/5 are coloured. With the above discussion, we arrive at the definition of fractions. Fraction. A fraction is a number representing a part of the whole. A fraction is of the form a/b, where a and b are whole numbers and b not equal to 0. In a/b, a is called the numerator and b is called the denominator. Examples. In 1/4, 1 is numerator and 4 the denominator. In 5/6, 5 is numerator and 6 the denominator. In 3/7, 3 is numerator and 7 the denominator. Example 1. I had 12 toffees. I gave half of those to Rishi. How many toffees did I give? Solution. Total toffees is equal to 12. I gave Rishi 1/2 of 12 toffees, which is equal to 6 toffees. I gave 6 toffees to Rishi. Example 2. Write the fraction for each of the following: 1/7, 2/3, 5/6, 3/8. Solution. 1/7. This implies 1 out of 7, which is equal to 1/7. 2/3. This implies 2 out of 3, which is equal to 2/3. 5/6. This implies 5 out of 6, which is equal to 5/6. 3/8. This implies 3 out of 8, which is equal to 3/8. Representation of fractions on the number line. We have learnt to represent whole numbers on the number line. Many numbers lie between any 2 consecutive whole numbers. For example, 1/5, 2/3, 2/5, 7/10 lie between 0 and 1. We can show the fractions on number line. Example. Show 1/2 on the number line. Solution. We draw a number line. We know that 1/2 is greater than 0 but less than 1. We divide the length between 0 and 1 into 2 equal parts and show one part as 1/2. Types of fractions. Like fractions. Fractions having the same denominators are called like fractions. For example, 1/5, 3/5, 4/5 are like fractions. Unlike fractions. Fractions having different denominators are called unlike fractions. For example, 2/3, 3/4, 1/5 are unlike fractions. Proper fraction. A fraction whose numerator is less than the denominator is called a proper fraction. For example, 5/7, 3/5, 1/3 are proper fractions. Improper fraction. A fraction whose numerator is greater than the denominator is called an improper fraction. For example, 7/5, 8/3, 4/3 are improper fractions. Unit fraction. A fraction having numerator as 1 is called a unit fraction. For example, 1/2, 1/3, 1/5, 1/7 are unit fractions. Mixed fraction. A fraction which is a combination of a whole number and a proper fraction is called a mixed fraction. For example, 2 and 1 upon 3, 3 and 2 upon 5, 4 and 2 upon 7 are mixed fractions. All mixed fractions can be expressed as improper fractions. Example: choose the like pairs and unlike pairs of fractions from the following: 3 upon 8, 5 upon 8, 7 upon 9, 4 upon 7, 2 and 1 upon 3, 3 and 1 upon 3, 6 upon 19, 14 upon 19, 4 and 1 upon 13, 3 and 1 upon 15, and 5 and 1 upon 8, 8 and 1 upon 5. Solution: we know that like fractions have common denominator, whereas unlike fractions have different denominators. Like fractions are 3 upon 8, 5 upon 8, 2 and 1 upon 3, 3 and 1 upon 3, 6 upon 19, 4 upon 19, because they have common denominator. Unlike fractions are 7 upon 9, 4 upon 7, 4 and 1 upon 13, 3 and 1 upon 15, and 5 and 1 upon 8, 8 and 1 upon 5, because they have different denominators. Example: which of the following are improper fractions? 7, 3 upon 13, 23 upon 9, 11 upon 3, 5 upon 7, 23 upon 19, 17 upon 6. Solution: we know that in improper fractions, the numerator is greater than the denominator. The fractions 7 upon 1, 23 upon 9, 11 upon 3, 23 upon 19, and 17 upon 6 are improper fractions, as their numerator is greater than their denominator. Conversion of fraction. Conversion of an improper fraction into a mixed fraction. We can convert an improper fraction into a mixed fraction by the following steps. Step 1. Divide the numerator by the denominator. Step 2. Write the quotient as a whole number and the remainder as the numerator of the fractional part. Step 3. The denominator of the improper fraction becomes the denominator of the fractional part. Example: convert 7 upon 5 into a mixed fraction. Solution: divide the numerator 7 by the denominator 5. Here, 1 is the quotient, which becomes the whole number. 2 is the remainder, which becomes the numerator of the fractional part. 5 becomes the denominator of the fractional part. Therefore, 7 upon 5 is equal to 1 and 2 upon 5 as a mixed fraction. Conversion of a mixed fraction into an improper fraction. A mixed fraction is a combination of a whole number and proper fraction. For example, 3 and 1 upon 2 is equal to 3 plus 1 upon 2. 5 and 2 upon 3 is equal to 5 plus 2 upon 3. We can convert a mixed fraction into an improper fraction by the following steps. Step 1. Identify the whole number, numerator and denominator of proper fraction. Step 2. Multiply the whole number with the denominator of the fraction and to this add the numerator of the fraction. Step 3. Step 2 will give the numerator of the required improper fraction. Its denominator will be the same as the denominator of the fractional part. Example: convert each of the following into an improper fraction. 3 and 5 upon 7. Solution: 3 and 5 upon 7 is equal to 3 into 7 plus 5 upon 7, which is equal to 26 upon 7. 6 and 2 upon 3. 6 and 2 upon 3 is equal to 6 into 3 plus 2 upon 3, which is equal to 20 upon 3. Equivalent fractions. Look at the adjoining figures. Figure 1 has been divided into 2 equal parts and shaded part represents 1 upon 2. Figure 2 has been divided into 4 equal parts. Out of 4, 2 parts have been shaded. The shaded parts represent the fraction 2 upon 4. Figure 3 has been divided into 8 equal parts. Out of 8 parts, 4 parts have been shaded. The shaded parts represent the fraction 4 upon 8. If we place the pictorial representation of one over the other, they are found to be equal. The fraction 1 upon 2 can be expressed as 2 upon 4, 4 upon 8, and many other more ways. We can write 1 upon 2 equal to 2 upon 4 equal to 3 upon 6 equal to 4 upon 8 equal to 5 upon 10, and so on. The above fractions being equal in value are called equivalent fractions, as they represent same part of the whole. From above, we observe that the value of fraction does not change if the numerator and denominator are multiplied by the same non-zero number or divided by the same non-zero number. Let us consider examples to illustrate it. Example: write 4 equivalent fractions of 2 upon 5. Solution: the equivalent fractions of 2 upon 5 are 2 upon 5 equal to 2 upon 5 into 2 upon 2 equal to 4 upon 10. 2 upon 5 equal to 2 upon 5 into 3 upon 3, which is equal to 6 upon 15. 2 upon 5 equal to 2 upon 5 into 4 upon 4, which is equal to 8 upon 20. 2 upon 5 equal to 2 upon 5 into 5 upon 5, which is equal to 10 upon 25. Hence, equivalent fractions of 2 upon 5 are 4 upon 10, 6 upon 15, 8 upon 20, and 10 upon 25. Simplest irreducible form of a fraction. A fraction is said to be in its simplest, lowest form if its numerator and denominator have no common factor except 1. When both the numerator and denominator of a fraction are divided by a number greater than 1, we say that the fraction is reduced to its lowest terms. There are two methods to reduce a fraction in its simplest form: prime factorization method, HCF method. Prime factorization method. Step 1. Express the numerator and the denominator of a fraction as a product of its prime factors. Step 2. Cancel the factors that are common to both numerator and denominator. Example: reduce the following fractions into their lowest terms: 36 upon 63, 48 upon 112. Solution: given fraction is 36 upon 63. Numerator is equal to 36. 36 is equal to 2 into 2 into 3 into 3. Denominator equals 63. 63 is equal to 3 into 3 into 7. Therefore, 36 upon 63 is equal to 4 upon 7 is the required fraction in the simplest form. 48 upon 112. Numerator is equal to 48. Denominator 112. 48 upon 112 is equal to 3 upon 7 is the required fraction in simplest form. HCF method. Step 1. Find the HCF of the numerator and denominator of the given fraction. Step 2. Divide the numerator and denominator by their HCF. Example 1. Reduce the following fractions into their lowest terms: 63 upon 24, 45 upon 60. Solution: the given fraction is 63 upon 24. HCF of 63 and 24 is equal to 3. 63 upon 24 is equal to 63 divided by 3 upon 24 divided by 3, which is equal to 21 upon 8. The given fraction is 45 upon 60. HCF of 45 and 60 is equal to 15. 45 upon 60 is equal to 45 divided by 15 upon 60 divided by 15, which is equal to 3 upon 4. Comparing fractions. We have already learned how to compare natural numbers, whole numbers, and integers. Here we will learn to compare the fractions. Rule 1. If two fractions with same denominator are given, the one with greater numerator is greater of the two. For example, 4 upon 5 greater than 3 upon 5, 7 upon 11 greater than 5 upon 11, 8 upon 9 greater than 2 upon 9. Rule 2. If two fractions with the same numerator are given, the one with smaller denominator is greater of the two. For example, 3 upon 5 greater than 3 upon 9, 4 upon 7 greater than 4 upon 11, 6 upon 13 greater than 6 upon 17. Two fractions can also be compared by cross-multiplication method. Example: compare the following fractions: 3 upon 8 and 5 upon 6, 4 upon 5 and 6 upon 7. Solution: 3 upon 8 and 5 upon 6. This implies 18 less than 40. This implies 3 upon 8 less than 5 upon 6. 4 upon 5 and 6 upon 7. Cross multiply 28 less than 30. This implies 4 upon 5 less than 6 upon 7. To compare two or more fractions, if there are two or more than two fractions, then we find the LCM of their denominators. We make the denominator of each fraction equal to the LCM to convert fractions into like fractions. Then compare the numerator of fractions. Example: compare the following fractions: 4 upon 5 and 3 upon 4, 7 upon 9 and 13 upon 18. Solution: 4 upon 5 and 3 upon 4. LCM of 5 and 4 is 20. 4 upon 5 is equal to 4 into 4 upon 5 into 4, which is equal to 16 upon 20. 3 upon 4 is equal to 3 into 5 upon 4 into 5, which is equal to 15 upon 20. Since 16 upon 20 greater than 15 upon 20, this implies 4 upon 5 greater than 3 upon 4. 7 upon 9 and 13 upon 18. LCM of 9 and 18 is 18. 7 upon 9 is equal to 7 into 2 upon 9 into 2, which is equal to 14 upon 18. 13 upon 18 is equal to 13 into 1 upon 18 into 1, which is equal to 13 upon 18. Since 14 upon 18 greater than 13 upon 18, therefore 7 upon 9 greater than 13 upon 18. Addition and subtraction of like fractions. Look at the adjoining diagram, figure 1. There are 4 rows and 3 columns. There are 3 boxes in each row and 4 boxes in each column. Total number of boxes equals 12. Out of 12 boxes, 3 boxes are shaded blue, that is, 3 upon 12 are shaded blue. Out of 12 boxes, 4 boxes are shaded black, that is, 4 upon 12 are shaded black. Total shaded boxes is equal to 3 upon 12 plus 4 upon 12. Count the total shaded boxes in the figure 1. These are 7 out of 12, that is, 7 upon 12. Therefore, 3 upon 12 plus 4 upon 12 is equal to 7 upon 12. The sum of two or more like fractions can be obtained as follows. Step 1. Add the numerator of fractions. Step 2. Retain the common denominator. Step 3. Write the fraction as sum of numerators upon common denominator. Example. Add the following fractions: 1 upon 5 plus 3 upon 5, 2 upon 7 plus 4 upon 7. Solution: 1 upon 5 and 3 upon 5 are like fractions. Therefore, 1 upon 5 plus 3 upon 5 is equal to 1 plus 3 upon 5, which is equal to 4 upon 5. 2 upon 7 plus 4 upon 7. 2 upon 7 and 4 upon 7 are like fractions. Therefore, 2 upon 7 plus 4 upon 7 is equal to 2 plus 4 upon 7, which is equal to 6 upon 7.
Just like addition of like fractions, the difference of two like fractions can be obtained. Step 1. Subtract the smaller numerator from the bigger numerator. Step 2. Keep the common denominator same. Step 3. Write the fraction as bigger numerator minus smaller numerator divided by common denominator. Example 2. Simplify 5 divided by 6 minus 3 divided by 6. Solution: 5 divided by 6 and 3 divided by 6 are like fractions. 5 divided by 6 minus 3 divided by 6 is equal to 5 minus 3 divided by 6 is equal to 2 divided by 6 is equal to 1 divided by 3.
Addition and subtraction of unlike fractions. We have learnt addition and subtraction of like fractions. In order to add or subtract unlike fractions, we convert fractions to equivalent like fractions and then we add or subtract them. The steps involved in the process are as follows. Step 1. Find the LCM of the denominators. Step 2. Convert each fraction into equivalent fraction with denominator equal to the LCM obtained in previous step. Step 3. Add or subtract like fractions as required. Following examples illustrate the above procedure. Example: add 3 upon 7 and 3 upon 5. Solution: to add 3 upon 7 and 3 upon 5, we take LCM of 7 and 5, which is equal to 35. 3 upon 7 plus 3 upon 5 is equal to 3 into 5 upon 7 into 5 plus 3 into 7 upon 5 into 7, making equivalent fractions with denominator 35, which is equal to 15 upon 35 plus 21 upon 35, which is equal to 36 upon 35, which is equal to 1 and 1 upon 35.